Solid-state batteries are making waves as the latest buzzword in the battery world, touted as a revolutionary technology poised to redefine electric vehicles and portable electronics. But can they truly live up to the hype? The answer is still evolving. However, a game-changing breakthrough by TDK Corporation, a prominent player in the electronics industry, could reshape the conversation. They have introduced a cutting-edge material for solid-state batteries with a staggering 100-fold increase in energy density compared to today's options. Imagine a future where electric cars can travel much farther on a single charge or smartphones last for days without needing a recharge. This innovation offers a glimpse into that reality. How exactly did TDK achieve this leap, and what does it mean for the electric vehicle industry? Let us uncover the details. For many drivers, range anxiety, the fear of running out of power before reaching a destination, is a significant barrier to embracing electric vehicles. TDK's groundbreaking advancement offers a promising solution. Drawing inspiration from the brand's legacy of innovation, including its iconic cassette tapes, TDK has unveiled a new frontier in battery technology, the solid-state battery. Unlike traditional lithium-ion batteries that use a liquid electrolyte, solid-state batteries rely on a solid material for their internal workings. This solid-state design holds the key to the breakthrough. TDK's innovation boasts a massive leap in power compared to their previous attempts. Imagine a car battery that acts like a supersized gas tank, allowing you to travel much farther on a single charge. This new battery packs 100 times more energy than its predecessors. Placed inside a smartwatch, the new battery could keep a device running multiple times longer than current battery technologies. The Apple Watch currently lasts up to 72 hours in low-power mode before it needs recharging, meaning it could potentially last several weeks with an improved battery life. Other potential applications beyond wearables could include environmental sensors, according to TDK. While the initial application of this technology targets smaller devices like headphones and smartwatches, the ultimate goal is to scale it up for electric cars. With this powerhouse battery, electric vehicles could potentially travel a staggering 1,500 kilometers or 930 miles on a single charge. That is more than 3 times the range of most electric vehicles on the road today. This significant improvement would drastically reduce range anxiety and make electric cars a far more appealing option for drivers who frequently travel long distances. The benefits extend beyond just range. Solid-state batteries boast a safety advantage because they eliminate the risk of flammable liquids present in traditional lithium-ion batteries. Additionally, they may offer much faster charging times, significantly reducing the time spent waiting at charging stations. This translates to quicker commutes and honestly less disruption to daily routines. The CEO of TDK is, really enthusiastic about the company's breakthrough. He envisions their newly developed solid-state battery material playing a pivotal role in a large-scale shift towards a more sustainable and energy-efficient future. This technology has the potential to, revolutionize the way we power our society. However, the path from groundbreaking innovation to widespread adoption is not always smooth. Unlike conventional lithium-ion batteries that use a liquid electrolyte, TDK's solid-state design relies on a solid ceramic compound made of oxides. This solid ceramic acts as a bridge for lithium ions to flow between the battery's 2 components, the lithium alloy anode and the cathode. While this solid approach offers significant advantages, it also presents technical hurdles. Maintaining a stable connection between the solid electrolyte and the electrodes proves more challenging compared to liquid electrolytes. Additionally, the entire battery needs to operate under pressure, adding another layer of complexity to the design and manufacturing process. While technical advancements like TDK's new material are definitely exciting, the major hurdles really lie in cost and scalability. Manufacturing these batteries needs to become significantly cheaper and more efficient before they can truly compete with lithium-ion technology. Solid-state batteries also face technical challenges that require further refinement. One concern is the inherent brittleness of the solid electrolyte material. This brittleness has the potential to negatively impact the battery's lifespan, especially during repeated charging and discharging cycles. Additionally, solid-state batteries tend to perform poorly in cold temperatures, which could limit their range and effectiveness in certain climates. Despite these challenges, there is a potential niche where solid-state batteries could offer a significant advantage electric-powered heavy trucks. For example, these vehicles may not be well suited for lithium-ion technology due to limitations on range and charging time. Solid-state batteries, with their potential for longer range and faster charging, could be transformative for the electrification of heavy-duty vehicles. The widespread adoption of electric vehicles is crucial for achieving global climate goals. However, the limitations of current battery technology, particularly regarding energy density and charging speed, have been a significant bottleneck. This is where the promise of solid-state batteries becomes, critically important. By potentially offering a solution to these core limitations, they could really accelerate the transition to electric mobility far beyond current projections. The implications extend into the very design and functionality of future electric vehicles. With the dramatically increased range provided by a solid-state battery, the need for large, heavy battery packs could be reduced. This would allow automotive engineers to design vehicles with greater interior space, improved aerodynamics, and honestly, better overall efficiency. The enhanced safety profile also means that batteries could be integrated into vehicle structures in new ways, further optimizing design and performance. Beyond passenger cars, the impact on commercial and public transportation could be even more profound. Electric buses, delivery vans, and long-haul trucks, which require immense energy reserves and just can't afford lengthy downtime for charging, stand to benefit enormously. The combination of high energy density and rapid charging could, honestly, make electric propulsion a viable and economical choice for virtually every segment of road transport. This would lead to significant reductions in urban air pollution and greenhouse gas emissions from the freight sector. The ripple effects would also be felt in the energy grid itself. As solid-state batteries improve in capacity and longevity, they could serve as more efficient and safer storage units for renewable energy sources like solar and wind. This would help stabilize the grid by storing excess energy generated during peak times and releasing it when demand is high, facilitating a greater reliance on intermittent renewable sources. Nevertheless, the journey from laboratory breakthrough to mass production remains a formidable challenge. The science of creating a stable, high-performance solid electrolyte is only the first step. The next, and arguably more difficult phase, involves developing cost-effective and high-yield manufacturing processes. The industry must create new supply chains for the novel materials required and build factories capable of producing these complex batteries at a scale that can meet the enormous demand of the global automotive industry. While TDK's announcement is a significant and encouraging milestone, it's really just one part of a larger ongoing global race. Numerous other companies and research institutions are also pursuing their own versions of solid-state technology. This competitive landscape is healthy, since it drives innovation and increases the chances of overcoming the remaining technical and economic hurdles. The ultimate winner in this space might not be just one technology, but rather a combination of approaches that are, tailored for different applications. Solid-state batteries are generally considered safer because they don't use a liquid electrolyte, which is actually a potential fire hazard in traditional lithium-ion batteries. The use of solid materials in the battery's construction really enhances its stability and reduces the risk of thermal runaway, making it a more reliable and secure option for powering electric vehicles. The potential impact of TDK's breakthrough, honestly, extends well beyond individual consumers. It reaches the automotive industry as a whole. Car manufacturers have been striving to overcome consumer hesitance towards electric vehicles, especially among folks who depend on their cars for those long journeys. By offering a solution to range anxiety and enhancing the overall performance of electric vehicles, solid-state batteries could be, truly transformative in the push towards sustainable transportation. In recent years, there's been a growing emphasis on transitioning towards cleaner and more efficient modes of transportation to combat climate change and reduce our reliance on fossil fuels. Electric vehicles have emerged as a promising alternative